Good morning, students. In the previous lecture, we did exercise 11.2. Yes, and in that exercise, we began with the area of the general quadrilateral, the area of the parallelogram, the area of the rhombus, the square, the rectangle, and we also learned to find out the area of various polygons. How did we do that? We did it by cutting the polygon into convenient figures like triangles and trapeziums. So, we have done the area so far. These were the formula that we revised. I hope you have learned the formula by now. The quadrilateral is half d h1 plus h2. So I hope you remember what is d. D is the length of one diagonal, h1 is one altitude, and h2 is the second altitude. This is h2 and this is h1, right? The parallelogram was base into altitude. The rhombus was half d1 into d2. The rectangle is length into breadth and the square is side into side. So I hope these figures are all clear to you and you have learned the formula really well. Now we move on further in the chapter to solid shapes. So solid shapes are three-dimensional shapes. Now what does a three-dimensional shape or three-dimensional object mean? It means along with the length and the breadth there is a depth. We can call it the depth, or you can call this the length, this the breadth, and this as the height. So when an object has got three dimensions, they are solid shapes. So solid shapes have got three dimensions. In the cuboid, we have a length, a breadth, and a height. In a cube, the length, the breadth, and the height are all equal. So if we call the length L, then the breadth is also L and the height is also L. Why? Because in a cube, the length, the breadth, and the height is equal. In the similar way, we have a cone. What you can see in the cone, the base is a circle and the top is a point. So this comes in which category we have done before? This comes in the category of a pyramid. Yes, it is not actually a pyramid because it is curved, but it is similar to a pyramid. So what you can observe in the daily life, when you see the objects around you, you will find some objects are regular objects. Now why I use the word regular? Because they are made up of straight lines or certain curves. But pieces of stone, yes, crumples of paper, breadcrumbs, these are all irregular objects. They are three-dimensional, but they are all irregular objects. So regular objects are something which has got some definitive measure. For example, this cone has got a fixed radius r and a fixed height h. The sphere has got a fixed radius r. This is also the radius r. The cylinder has got a fixed radius r and a fixed height h. So you can see here in the cuboid we have got length, breadth and height. In the cube we have only the length. In a cone we have the radius and the height. In the sphere we have got only the radius, and in the cylinder we have got a radius and a height. So these are the dimensional objects, the solid shapes which have got three dimensions, the length, the breadth and the height. Okay, but like I told you, they are different from irregular objects like a piece of stone, a breadcrumb and so on. Now these three-dimensional objects, you can see in the real world I have shown you, This is a box that I have tried to show you. This is the object in the real world. So how many dimensions it has got? It has got 3 dimensions. The length, the breadth and the height. Now like we did in the previous lectures, I have got a figure here to explain to you what consists of this 3-dimensional object. So we have got the surface of this object. There are 6 surfaces to this object, 6 surfaces. You can see the 6 surfaces are also called the faces. So this one is surface 1 and opposite to it is surface 2. The blue color are surface 1 and surface 2. What do you notice? That they both are equal in shape. To the side is surface 3 and to the other side is surface 4. Those two surfaces are equal. And below the base is the surface 5 and the top is the surface 6. So 3-dimensional object in the real world is made up of 6 surfaces. So what you can do is that you can find out the area of each surface. You can find out the area of surface 1. How will you do that? You will multiply the length by the breadth, right? And surface 2 will also have the same area. Now the surface 3, which is on the side, has got a breadth and a height. So surface 3 can be found out by multiplying the breadth into the height. Surface 4 has got the same area. Surface 5, which is the bottom, has got the length and the breadth. So surface 5 has got length and the breadth, and surface 6 also has length and breadth. And surface 1 again has got length and height. So surface 1 is length into height. Now this 3-dimensional object has got 6 surfaces. Okay, they are also called the faces, which we did in the previous chapter. Now these surfaces are bound by lines. You can see surface number 1 is bound by 4 lines. These are called its edges. Yes, these lines are called as edges. So surface 1 has got 4. So these edges, we have to count how many edges in a cuboid. And you will see the edges of the surface terminate in these red colored points. These are the points which are called the vertices. So I hope you can recall from the previous chapter, every surface, a cuboidal surface has got faces, vertices and edges. Yes, and you must also recall the formula of Euler. What does it say? Faces plus vertices equal to edges plus 2. So in the cuboid there are 6 faces. There are the vertex is 1, 2, 3, at the bottom here 4, 5, 6, 7 and 8. So there are 8 vertices. The edges are 1, 2, 3, let me put it in blue or let us say green. The edges are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So we have got 12 edges and plus 2 is the formula. So 6 plus 8 is 14 and 12 plus 2 is 14. So this formula we did in the previous lecture. Now what are we going to see now is to find the surface area of these figures. So we'll just recall what we have just done. In the real world, we have got objects made up of 3 dimensions. The real world objects are mostly in 3 dimensions: the length, the breadth and the height. But this 3-dimensional object has got surfaces. This is surface 1. So I have indicated as a surface 1. Now the surface has only got 2 dimensions: the length and the breadth. So you can see a three-dimensional object has got 6 surfaces, but those surfaces have only got 2 dimensions, length and the breadth. Now this surface is bound by a length. So length has only got 1 dimension. And on this length, on this line, there are infinite points and 2 endpoints. Points have got no dimension. They have got 0 dimension. They are represented by a dot, but points have got 0 dimensions. Length is 1 dimension. Surface is 2 dimension. And volume or real body is a 3 dimension. So what we are supposed to do in today's lecture is go to the different shapes and find out their surface area. So first we begin with the cuboid. You can see this box, it is given in a textbook, is in the shape of a cuboid. So you can look at an empty toothpaste box. Yes, the empty toothpaste box is in the shape of a cuboid. Now what they have done here is, they have opened this box. Yes, all the edges, they have torn it from one side and opened up the box. So what does this toothpaste box have? It has got a length L given here. It has got a breadth B and a height H. Now when you open it up, how many surfaces are formed? There are 6 surfaces. So this they have called surface 1. Yes, this is the surface 1. On the side, on the top, this top is surface 2. So they opened the surface on the top. This is surface 2 on the top. This is surface 1. This is surface 1 and the top is surface 2. Adjacent to 1 is surface 3. So they have put surface 3. So we have got 1 and 3. And opposite to 3 we have got the surface, opposite to 1 we have got the surface 4. So you can see surface 1 and surface 4 are equal. On the back side of 3, opposite side to 3, we have got the surface 5. So this is the surface 5. You will observe 3 and 5 are equal. And the bottom is surface 6. And we will observe surface 2 and surface 6 are equal. So this cuboid is made up of 6 surfaces. Now, if I want to find out the total surface area of the cuboid, we'll call it TSA, the total surface area of the cuboid. So till the previous lectures, we had learned how to find out the surface area of 2-dimensional shape. Now we are going to a 3-dimensional shape. The first we have taken is the cuboid, which is made up of 6 sides. To find the surface area of the cuboid, we will have to add the surface area of all the 6 sides. So let us begin how to find the TSA. So area 1 is in the form of a rectangle. You must have noticed area 1 is in the form of a rectangle. The length is L and the height is H. So the area of this rectangle, surface 1, will be length into height. Actually area of rectangle is length into breadth, but here we have got length and the height. So the area of this rectangle, that is surface 1. This surface 1 will be length into height. To that we will add the surface 2. Which is the surface 2? The one on the top. So this is also in the form of a rectangle whose area will be length into breadth. So we will write here length into breadth. Moving to surface 3. Surface 3 is also a rectangle whose breadth is B and height is H. This is the height H. So we have got breadth into height. Surface 4 is length into height. So we will write here length into height. Surface 5. Can you guess surface 5? Is a rectangle, breadth and height. So B into H. And surface 6 is this one, which is length into breadth. So length into breadth. Now what do you observe? The length into height. is 2 times. So I take 2 times length into height plus the breadth into height is 2 times. So 2 times breadth into height, and the length into breadth is 2 times. So 2 times length into breadth. If we take the 2 common, we get L into H, which can be written as just LH, means L into H. B into H can be written as BH, and L into B can be written as LB. So this is the formula to find out the total surface area of a cuboid. Now remember, the total surface area means the surface of all the 6 sides together. And this happens because 1 and 4 are equal in area, 3 and 5 are equal in area, 2 and 6 are equal in area. So we have derived the formula to find out the total surface area of a cuboid, all the 6 sides. So learn this formula thoroughly and let us try out a few sums. Find the total surface area of the following cuboids. Now the dimensions are given 6, 4 and 2. So we can take the way we want. It is not mentioned which is the length, which is the breadth, which is the height. So we shall take L equal to 6, B equal to 4 and H equal to 2. So what is the TSA of the cuboid 1? TSA, first we write down the formula, 2 LH plus BH plus LB. Put down the values. 2, L is 6, H is 2. So 6 into 2 plus B is 4 and H is 2. So 4 into 2 plus L is 6 and B is 4. So 6 into 4, which gives us 2. 6 2s are 12 plus 4 2s are 8 plus 6 4s are 24. So we have got 2 into 12 plus 8 is 20, 20 plus 24 is 44, and 2 into 44 is 88. Now since it is given in centimeter, the area will be in centimeter square. So it's a very simple formula. I hope you have understood it, and we have to calculate the total surface area, all the 6 sides. Now pause the video here and try out the second sum on your own, where the length is 4, breadth is 4 and height is 10. Pause the video, try out the sum and then look at the solution. Okay, so have you done the sum? Let us check the answer. The TSA, first we write the formula, LH plus BH plus LB, 2 into 4 into 10 plus B into H 4 into 10 plus LB 4 into 4 equal to 2. 4 tens are 40 plus 4 tens are 40 plus 4 fours are 16. 2, 40 plus 40 80, 80 plus 16 96, 96 twos are 192 centimeter square. So I hope you have got the correct answer. If you have, means you have understood the topic really well. So it is a very simple topic. From two-dimensional object we have moved to a three-dimensional object, and the total surface area is the sum of the area of all the 6 sides. Yes? If you have not understood it, kindly rewind the video and see it one more time. It's really very simple. After the cuboid, we'll move on to the cube. Now what I said, what is a cube? In the cube, the length, the breadth and the height is equal. So if you look at the front side, this surface 1, and the opposite side, or on the side, let us take the top as 2. So 2 is on the top, right? In the previous figure, 1 is in the front and 2 is on the top. So surface 2. and 1 on the side is 3. Opposite to 1 on the other side is 4. Opposite to 3 on the other side is 5. And the bottom is 6. Now what you can see is, because the length, the breadth and the height is equal, you will see all the 6 figures are equal. All of them are equal. In a cube, all the sides are equal, so all the surfaces are also equal. So TSA of cube, the TSA of cube will be 2. Now instead of LB, we write L into L. Instead of BH, we write L into L. Instead of LB, we write L into L, because all the sides are equal. So it is 2L square plus L square plus L square. That is 2 into 3L square or 6L square. Or you can see directly the area of this square is L into L. So L square. And since all the areas are equal, so 1, 2, 3, 4, 5 and 6. You can directly write TSA of a cube is 6L square. So the only difference in a cuboid and the cube is that in a cuboid we have got a length, breadth and height, in which the length, breadth, height are different, and in a cube all the sides are the same. So the total surface of the cube formula is very easy, 6L square. So let us revise both the formula once again. TSA of a cuboid. The TSA of a cuboid is what? 2 into bracket LH plus BH plus LB. And for a cube, it is 6L square. Now the sum. Find the surface area of cube A and cube B. If you want, you can pause the video here, try out both the sums on your own and then check your answers with mine. Okay, so have you finished the sum? So TSA of cube A, what is the formula? 6L square. What is L? L is given 10. So 6 into 10 square. That is 6. 10 square means 10 into 10. 10 tens are 100. So the answer is 600 centimeter square. TSA of cube B. Same formula, 6L square equal to 6 into the length is 8. So 8 square equal to 6 into 8 8s are 64. So 64 into 6. How much is 64 into 6? 6 4s are 24. 32, 6 is a 36 and 3. 384. So 384 centimeter square is the area, total surface area of cube B. So we have only done 2 topics so far, total surface area of a cuboid and total surface area of a cube. For the homework we have got exercise 11.3, sum numbers 1 to 4. You have to do the sums in your homework book. This is all for today. I hope you enjoyed the lecture. Have a good time. Thank you.